Okay, so we're going to be talking about log division of polynomials. And so what we're actually going to do, right, with these rational expressions is we're going to actually do the log division. But before we do that, let's go back again, start with the basics when we're talking about just numbers themselves. So if you have a number like 32 or 5 and you want to apply the log division to that, you would write the number that you're dividing with on the outside and the number you're trying to divide on the inside. Okay? And then you ask yourself the question, what times this gives you a number which is smaller than that, but cannot add 5 more, right? And it won't be over. So 6, right? 6 times 5 gives you the 30. And then once we have this number, you subtract it straight down, so you get 2. And then you ask yourself again, right? What times this 5 will give you a number which is below this one, where the number one above it won't be multiplied to be higher than this. So notice that we can't do that, right? Because 5 is already smaller than 2. So the way we would write this before, right, is 32 over 5 is 5 with remainder 2, actually, is the way that most people write it. Like that. But the way that we write it in math is actually written as 5 plus 2 out of 5. Okay? So this right here is something called the quotient. This part up here is the remainder, and that's the divisor, right, or g of x in this case. So what I'm going to do now is I'm going to show you that this can be translated into our rational expressions version. So in our rational expression version, we have f over g. Well, we just said that this is going to equal a quotient. So we call that quotient q. And it's going to be added to some remainder. And the two divisions, right, this part over here and this part over here, they're the same. So that's the bottom part of this fraction. So this is going to be divided by g of x. So our answers are going to be written in this form, where it's f divided by g, so like f divided by g, is equal to the quotient, which is, well, I'm sorry, these are 6's. Quotient here plus the remainder divided by g. Okay? Now, in this problem, where we're talking about the remainder and the division by g, there is a special property. The degree of r is smaller than the degree of g. So when you're doing this long division and going through this process over here, you'll know when to stop when the degree of the remainder, or this bottom part over here, after you do this subtraction part, is smaller than the degree of the thing you're trying to divide with. So let's just go ahead and do these examples. The first one that we're going to do, you can do with long division. However, when you have a monomial like this, which means one term, there's no addition, there's just a single term inside. What you're going to do is you can just split it by distributing the division to each of the terms in the numerator. So I can write it like this. And then use your exponent rules to start simplifying or canceling, right? We have 3 x's here, so those cancel, and you're left with 3 over 2x. These two cancel, so you're left with 1 over 2. Here, this and this cancel, and you're left with 2. And then this one, there's nothing to cancel, which is 3 over 2x squared. Yep. Now, we can leave it like this, right? If we were to write it out, that part here, That is going to be our quotient. The remainder part is actually this part over here. And if you rewrote it, let's say I multiplied the top and the bottom by 2x instead, what you would get here is plus 4x over 2x squared plus 3 over 2x squared. And this blue part is going to be 4x plus 3 all divided by 2x squared. So this part over here, that's r of x. This bottom part, that's our g, right, given up here. So this quotient plus remainder over g, you could still write it in that form using the division where we distribute the division of the 2x squared. Now, either way is fine, right, depending on what your teacher is requiring me to do. Yeah? I just wanted to show this so that you could see that the division, which we're going to do now, which is the long division, is going to apply to either case. Meaning, if you want to apply what we're going to do here to this problem, you can. So notice that this problem doesn't have a single term on the bottom, right? There are 3. So because of that, we're going to do long division instead. And the way to do it is the same way that we did the regular numbers. So the bottom goes on the outside. Inside the division, you want to write the polynomial on the top. But the polynomial on the top, what you want to do to help you keep track of everything is write out the 0 t squareds, t cubes, whatever is missing, so that you can keep track of the powers. So really, there's 0 t cubes, 0 t squareds, but negative 13t minus 42. So these ones in the middle, right, they're missing up there. But we write them just for the sake of keeping track of the exponents. And you'll see that when we start doing the problem. So the way to do these long divisions is using that exact same process. The question is going to be what times this in the front, or the degree, the exponent, which is attached to the t, which is the degree. What times this one gives you the first term? So everyone see t squared. So this is the reason, right? You want to start lining things up. You see how it's above the t squared section. Once we have that number, we ask ourselves to do the multiplication itself. This times the whole thing gives you t to the 4th minus t to the 3rd minus 6t squared. Now, there's 2 ways to do this one. You can subtract it and then subtract straight down, which is what we did when we did the long division with numbers. I personally would rather add, and the way that you do that is you just change the signs. So just change all the signs and then add straight down. So if you add these 2 together, you get these cancel. If you add these 2 together, you get t to the 3rd. Add those together, you get plus 6t squared. Another trick to keeping track of the long division is at every point that you get to this step where we do the addition, bring everything else down. Like that. And then go ahead and ask yourself the same question again. What multiplied to the t squared will give you that one? So is everyone okay with t? So do the multiplication. T times this is t to the 3rd. T times the next one is minus t squared. And t times the last one is minus 6t. Change the signs. And then now add straight down. So these cancel. 7t squared. This is going to be minus 7t minus 42. And you keep going. How do you know that you keep going? Because the degree here is not bigger than that one. Okay? Remember, we want this degree, the r of x, to have a degree which is smaller. So what times t squared gives you 7t squared? 7. So do the multiplication. 7t squared minus 7t minus 42. Change the signs and then add straight down. So this, and that, they all cancel. So when we finish our problem, this gives you 0. The bottom part over here is the remainder. This top part over here is the quotient. This part over here is g. And the part inside here is f of x. Okay. So now we can write out the equation, right? It's f, which is going to be t to the 4th minus 13t minus 42 divided by t squared minus t minus 6. This is f over g is equal to q plus r, which is 0 over g of x. So I'll go ahead and write the colors again. This is f. This is g. So is this. R is going to be the top part. And the quotient is this part. Now, because this is a 0 remainder, you don't need this, but I wanted to write it so that everybody can see where all the parts went into the actual writing of the solution. So this entire statement out here is the solution without this if